Section 2.3 is called the Product and Quotient Rules. We won't get to the quotient rule today, but we will look at the product rule. The basic and overall question about the product rule, and the mistake that a lot of people tend to make when they use or when they see a product, is that they try to do this right here. They want to be able to say that when you're taking the derivative of a product, that it's just the product of the derivatives. That's what we wish it were true. It'd make my life easier, right? It would look a lot more like that sum and difference rule that we had if this were only true. So I want to show you a very specific example so that you can see why and how it fails. Okay? So it says to consider the function f of x equals 4x to the 9th and g of x equals x cubed. And there's nothing special about these functions except that they were simple to work with. They were small, they were fairly clean. Okay? So if we were to take the product and then the derivative, it means that we should multiply these together first. So in other words, what is 4x to the 9th times x cubed? What is that? Yeah, it's 4x to the 12th. So if I were to have now 4x to the 12th, because I multiplied first, and then I took the derivative, what is the derivative of 4x to the 12th? You're close, 48. Yeah, 48 and then x to the 11th. I think you were looking at the one before it, weren't you? Yeah. Yeah, and we'll do that one here in just a second. So if we multiply the functions first and then we take their derivative, I get 48x to the 11th. Everybody see what I did with that? Multiplied the functions first, then took the derivative. So the question sort of is this idea of commutative, right? Well, could I do it in the other order? That's what commutative means, is that the order doesn't matter on something. So what if I took the derivatives first? In other words, what is the derivative of the 4x to the 9th? I'm going to write these in. Don't say anything just yet. And then we're going to multiply that answer by the derivative of x cubed. So what is the derivative of 4x to the 9th? 36x to the 8th. What's the derivative of x cubed? 3x squared. Now then, what is the product of 36x to the 8th times 3x squared? 108x to the 10th. And the answer to the original question is basically that these two are not equal, right? The order did matter. It mattered whether I multiplied first and then took the derivatives or whether I took the derivatives first and then I multiplied. So what that tells you is that obviously I don't end up with the same answer in whichever direction I go. So that I can't do that. This is not the product rule. It will not give you the correct answer. So if this isn't the product rule, and we're crushed beyond belief now because this didn't work, what is? Well, this is actually the product rule. What the product rule says that I need to do is I do need to take their individual derivatives, but I don't just multiply those derivatives together. I take the derivative of one piece and I multiply it by the original of the other piece. And then whichever one of those I did first, I do the other one after that, and I add them together. Now, the way that I wrote it down, the order in which I wrote it down on the right-hand side is simply the order that I'm most, not comfortable exactly, but it's the order I use the most. It's just the one that I always go to. I always do it in this order for me personally. Your book actually expresses it flipped, the order flipped. And that's okay too. It doesn't hurt anything. There's nothing wrong with that. It's just the different ordering because addition is commutative. 5 plus 3 is 3 plus 5. Doesn't matter which order I do those in. So if I take these and I switch this, that's totally cool. There's nothing wrong with that. So if you don't like my ordering because you already learned it in a different way, or you just think it makes more sense a different way, then do it the other way. It doesn't matter. Okay? So let's do an example so you can see, and I'll explain to you also why I like my ordering. Now, let me first identify for you that this particular problem, you really don't need the product rule to do it. Could you multiply this out and then actually take the derivative? Of course, because neither of these are very complicated. They're just, it's foiling, right? You could do this problem without the product rule, okay? So I wanted to start, though, with something very simple and clean so you can see how it worked without getting all of the mess involved in doing it. So here's the deal. The product rule says least my version of it, the order in which I do, says the first piece, you just draw it down. You rewrite it exactly as is. And that right there is the reason that I like this ordering best, is because you can always start the problem. No matter what it looks like, you just rewrite the first piece. The second thing I'm supposed to do is to take the derivative of the second piece. So I need the derivative of x squared minus 5. It is just 2x. Very good. I'm half done, because then I have a summation. I have to add. And I want to do things in the other order. So I go back to the first part, x squared minus 3, and I take the derivative of that piece. So what's the derivative now of x squared minus 3? I'm sorry, plus 3. X squared plus 3. 2x. And I multiply that by the original of the second piece, which is x squared minus 5. And at that point, the calculus is done. Okay? You're going to take a quiz for me, and I don't know, I think it's next week sometime, I think, called a gateway, right? And I mentioned this last time when I said it. You would be able to stop at the point right here. This is all the calculus there is. On your homework, on your quizzes, on your exams, you would not stop here. You're going to clean this up. Okay? You're going to do the algebra to finish the problem off. So it has been said before that you're never as good as you are at algebra until you take calculus. Because we're going to keep working on those algebra skills all throughout calculus. Yes, Mooney?
I have to redo it all.
Hmm?
I have to redo it all after we get the answer.
You have what?
I have a question.
When we get to the answer? Oh, okay. I'm sorry. Yes. All right, so we're going to multiply this out, right? So we're going to FOIL, we're going to factor, we're going, whatever word you like, we're going to distribute, okay? So x squared times 2x is going to be 2x cubed. 3 times 2x is going to be 6x. And then we'll do this over here as well. 2x times x squared is going to be 2x cubed. And then 2x times negative 5 would be negative 10x. We will combine like terms, and what will we get?
4x cubed minus 4x.
4x cubed minus 4x.
Question.
Yes?
So do you want to leave it that way, or do you want to factor 4x out of it?
Usually we will leave it like this.
Okay.
There will come a point when we will have a need to factor things out, because we're going to keep working with the problem to do something further. So when we have that happen, it'll be in chapter 3, and we'll talk about it then.
Okay.
Yeah. Okay. Everybody good with that? Okay, so it cleans up a lot, and you can kind of see at this point, especially on this one, why we would want to clean it up.
Do you care if I use U and V instead of F for X and G?
Nope, that's fine. That's another notation for it, depending on the resources you're using. That's fine. Okay, here's another one. This is actually a very good example for one that you could not do in any other way, right? The last problem, as we looked at it, we said, we don't really need the product rule. We could really just multiply that all out and then take derivatives, right? Yeah, you can't do that on this problem, because one's a trig function and the other is an algebraic expression, right? You can't do it any differently. So on this one, we need the product rule. It's still a fairly straightforward and simple one, but we need the product rule on this. So my first step that I do all the time is I write down the first piece exactly as is, x cubed. And then I look at cosine x and I say, what's the derivative of cosine of x? That is the negative sine of x plus. And I go in the other order. I need the derivative of x cubed. So what's the derivative of x cubed? 3x squared. And then the original of the second one, cosine of x. Again, that's all the calculus there is. And there's really not a lot of simplifying to do after this one either. So let me show you what there is. It's not especially nice to have this negative inside the sign in the parentheses, so I'm going to pull the negative to the front. Yes, Dawson?
Do you have to put parentheses around the cosine x, or can you just leave it?
You can just leave it. The reason I have the parentheses around the sine x is because it's got a negative with it. That's the only reason. And if it does have a negative with it, you do need those parentheses. Otherwise, it means subtraction.
Okay.
So that they are necessary on that one. The other piece, I really don't need to do anything. It's just going to be 3x squared cosine x. So like I said, there's hardly any simplifying to do on this one. Very, very minor, the negative at the beginning, and that's it. Any questions on this one?
That's it? That's the answer?
Yes, that's it. That's the answer. Because you can't combine them. I was looking to see if I see anything else. Okay. Let me just mention the quotient rule, and then we'll stop. We won't actually learn it today. The other rule in this section is the quotient rule. We're going to start in on this problem just like we did in the last problem, asking ourselves the same question. Wouldn't it be nice if we could just take the derivative of the top and the derivative of the bottom and just divide them? That would be so nice. Kind of like the product rule. Wouldn't it be nice if? And we're going to find out, of course, that we cannot. Okay, so we will do that next time.